In this video, we are going to go over some practice problems for our molarity calculations worksheet. So the molarity formula is right here. It's big M for molarity equals moles over liters. Now, depending on the information you're given in these questions, you're either going to be using the molarity formula by itself, or you're going to be using the molarity formula with the mole formula. So in this first problem, it's only the molarity formula. They tell you your molarity is you have 0.5 moles of sodium chloride, and you have half a liter, so they want the molarity. So you just solve for it, and you end up getting X equals 1 molar NaCl. That was a super easy one. Let's do number two. Number two requires a little bit more work. So number two says they want the molarity. So if I write my molarity formula out, they want the molarity. And they tell me that 80 grams is dissolved in 1.5 liters of sodium hydroxide. So I have 1.5 liters, and I can't put my 80 grams here because it's moles. So this is where the mole formula comes in. I know the formula, sodium hydroxide. I know I have 80 grams. I can solve for how many moles I get. So let's do the GFM of sodium hydroxide. Sodium on the periodic table, if I remember correctly, it weighs 23, but let's double check. So sodium weighs 23, so we've got we add them all together and we get 40 for the GFM of sodium hydroxide. So now I get 2 moles of NaOH. Then I take my 2 moles and I plug it in there. For my final answer, I get 1.3 molar NaOH. And there's your answer. All right, so there's the first two problems. So depending on the problem, you're either going to have to use the molarity formula or the mole formula, meaning both of them, or just the molarity formula because this is a molarity worksheet. Now, you don't necessarily always use them in that order. Sometimes they may give you molarity in liters and say how many grams is it. So in that case, you'd use the molarity formula to solve for moles, plug that in this way to this problem, and then figure out the grams. So just remember the mole number here and the mole number there, that's moles. So if it's the same problem, obviously, you could take the number from here and plug it in there. You could take the number you get from this equation and plug it in there. It can go in both directions. So just be aware of that. And now let's go to the very last problem, all the way at the bottom here, and it says how many liters of solution must 150 grams of magnesium nitrate be dissolved to make 2.5 molar solution? So let's take a look. So they want a 2.5 molar solution for this one. Okay, and they give me 150 grams, and I know the formula for GFM, or at least I can figure it out. Magnesium is Mg, nitrate is NO3 minus 1 plus 2. It's ionic, so I use the crisscross method, and I get MgNO3 twice. Okay, so I'm going to figure out the GFM for this. So the way I would do that is by, obviously, 1 Mg, which is 24, 2N, which is 28, and 6O, which is 96. Add all that up. And I get 148 for my GFM. Which gives me 1.01 moles. I can plug that in here. and then I solve for liters. So it's all the way at the bottom. It's a little bit hard to see, but I end up getting 0.41 liters of solution. So hopefully there's no questions there. I was just using it. The only thing that made this problem, I guess, a little bit more difficult was you had to figure out the formula for magnesium nitrate, and then use it in the mole formula and then plug it in. So it's really not much harder. It was just it added this one extra wrinkle on this type of problem.